All right, Algebra 2, as we get into a chapter about polynomials, we need to review some exponent rules. So here's a couple as we just kind of flip through them. The zero exponent, that just means that any base that we have, if we take it to the zero power, we're always going to get one. Okay, one SAT definition, right, it's undefined if you take 0 to the 0. Okay, so as long as you do anything else, 4 to the 0 power is 1, 2,500 to the 0 power is 1, right? If we did 2x to the 5th, y to the 3rd over z to the 12th, and took this to the 0 power, since it's all to the 0 power, it becomes 1. Okay, so don't let that trick. Negative exponents. So here's one that we have a little bit of misconception sometimes. Remember, everything in the world is a fraction. If it's not a fraction, make it look like one. It's over 1. So we're going to take the reciprocal. Notice it's now 1 over 8 to the nth power, and this is now positive. Now, this works the other way around as well. If it's in the denominator and has a negative exponent, it needs to end up as a positive exponent in the numerator. Okay, so we can flip those over. Now, what we're going to do is I'm going to ask you to be able to simplify and do some of these. So what you do is instead of giving me decimals for this, what you would do is say, okay, so that's 3 squared, so that's 1 over 9. Okay, so if this is from the denominator, it's going up top. So it's going to be 64. We should be able to do those, and we can work around our calculator. So it's not giving me the decimal value of 1/9. Just say that it's going to be 3 squared, which is 9, and put it in the denominator. The next thing we have is if you have multiply powers with the same base, okay, we're going to add the exponents. Okay, so what that means, if I see multiple bases, I should add the exponents. So we're going to get 2 to the 5th, which again, we're going to work on actually simplifying these, not just making them go together. Now, if it's a variable like we have up top, then that's going to be fine, right? So example, x to the 3rd, x to the 5th, right? That's going to give me x to the 8th because we have the same base. So that's where we're going to use our addition quotients. When we divide, we subtract. When we divide, we subtract. So this will end up as 9 when we get finally the whole way through it. Okay, x to the, let's go with 5th over x to the negative 6th. So this is the one I caution you of, right? This is 5 minus negative 6. So this is x to the 11th. Okay, so we are going to subtract as we do it. Okay, your other way around it, you know that some of these rules get a little bit mixed, is this should go up top as x to the 6th. And now it becomes the product property, right? So we're going to add them instead of subtract. So either way, it's x to the 11th. So let's be mindful of that as we work through our rules. Power to a power. Okay, so if you see multiple powers, we're going to multiply those. So 2 to the 6th. Why don't I have that one listed down here? Right? We had 2 to something else. 2 to the 5th is 32. So 2 to the 6th, 64. Okay, if we can use numbers, let's use numbers. What's going on with these examples? I don't know who made this up. All right, x to the 5th and x to, whoop, I don't want another x. We want to take that to the, let's say, negative 3rd. Okay, so x to the negative 15th. So remember, we always want to have final answers with positive exponents. So 1 over x to the 15th would be our final expression here. Just to keep that in mind, I want to throw in some of these with negatives as well, because that's what we're going to work on. All right. If we have multiple items inside there, okay, so typically this isn't even written this way. It would be, let's say, 2x to the 3rd, and let's square all this. Right, what we have to do is distribute that exponent to each item. And remember, everything has an exponent as well. So this would be 2 squared, and this would be x to the 6th. So 2 squared is 4. So it becomes 4 x to the 6th. All right, well, that's weird. It doesn't want to write anymore. All right, 4x to the 6th. All right, let's pause and see what's happening. All right, so it should be 4x to the 6th. Sorry about that hiccup there. Yeah, let's see, what else do we have going on? All right, so if we had multiple things in there in the parentheses, right, 2x cubed, all right, we can have the same thing here. And again, well, I guess this is a good enough example, but it can have, combine all these together as well. Okay, so if I have 2/3, and I need to square it, so I'm going to square the top, and I can square the bottom. Now what we can do is add on a bunch of stuff to this. So let's go with 4x squared, 5y cubed. All right, and let's take this to the negative second power. So a couple things happen is we're starting to layer all these rules in here. So everything's going to need squared, right? That's the first part here. The other part is it all needs flipped over. So as I square everything, I'm going to change its location. So 4 squared is 16. Notice where I put it. X squared squared is x to the fourth, so it's on the bottom. 5 squared is 25. And y cubed squared is now y to the sixth. And we're going to put that up top. Okay, so we're well beyond working in these in isolation. So that's our 7 rules. Okay. Now off the side here we have some to try out. Okay, so we're going to work with some of these exponent rules given the order of operations. Okay, so the first one, right, I have to take care of my square before I can multiply. So I know this is 25, so it starts off with 50. Okay, and negative 4 squared is 16, so I'm at 66. Okay, so we can work through some of those. Right, anytime I see something to the 0th power, right, since I'm multiplying, I can just scribble it out because it's times 1. If it was by addition, I'd have to make sure I put 1 in here. Okay, so here I'm going to say plus 1, whatever happens to the rest of it. All right, so we have a lot of these with the order of operations. Then we're going to start to layer these together. Okay, a lot of negative exponents. Okay, so in 11, I would encourage you just to make it 3 to the negative first, x squared y to the fourth. Okay, so only the 3 to the negative first is negative, so it's going to the bottom. Okay, remember it does have a 1, so power to a power we're going to multiply. So you can see in 12 we have a lot of layers going on. Okay, so just kind of grabbing a few of these here and there to try and help you out. Okay, so all of this being multiplied, so this all turns into 1. That's no big deal. And I might use simplifying everything inside first. So I'm going to deal with this by subtraction, deal with this by subtraction, and then finally take that, whatever that comes out to, I'm going to take that to the sixth. So 3, negative 3, minus negative, so that's plus 9, so that's y to the sixth. And 8 minus negatives, that's x to the ninth. Now I have a power to a power. Okay, so I might flip them around just so we're used to it. 54 y to the 36th. Okay, so it looks really big and complicated as far as how that's going to work, but one thing at a time working inside those parentheses. Okay, so in the bottom one here, I might even just clean up the entire bottom, right? So I'm going to square everything first. So p to the negative second, q to the negative eighth, p to the 10th. Okay, so I'm going to put these together, so it's p to the eighth, and now it's positive. Do the same thing through the top. Right, the first two terms, factors, they won't do anything, but p to the negative 6, q to the negative third. Okay, so I can get rid of this part here, negative 6, negative 6. So that means in the numerator I have p to the negative 12th, q to the fourth. It's over top of p to the eighth, q to the negative eighth. This eventually has to go to the third power, but again, I want to finish what's inside of here first. Okay, so I know these 12 are going to end up in the bottom. So that's 20 on the bottom. These 8 are going up to the top, so it makes q to the 12th up top. And now it's finally going to be to the third power. So q to the 36th over p to the 60th. Okay, so just do one thing at a time, do it well, and then you'll be just fine. All right, so if you know all your rules, right, these are going to be true, false. So this is getting really for your SAT readiness here. Right, and a calculator wouldn't help out with any of these anyway, so no big deal. So give those a try, true, false.